This screencast is on matter and some of its properties. So matter is anything that has mass and takes up space. So mass is a measure of the amount of matter. It's not the same thing as weight. We often think about weight and mass being the same thing, but they're not from a physical standpoint. And volume is the amount of three-dimensional space an object occupies. So everything around you is matter. Your desk at school, a rock. Believe it or not, even the air outside is matter. So everything that is around us is matter. The basic building blocks of matter are atoms, elements, and compounds. An atom is the smallest unit of an element that keeps the chemical identity of that element. You can't break the atom down any further than the atom, or else it changes into something. It doesn't have the same properties as the element. It's going to react differently. It's going to look differently. An element is a pure substance that cannot be broken down into simpler, stable substances, and is made with one type of atom. So the element carbon, it can't be broken down any simpler than carbon without turning it into something different. And all atoms of carbon look exactly like every other atom of carbon. So elemental carbon looks identical. A compound is a substance that can be broken down into simple, stable substances, and it's made from two or more atoms being chemically bonded. So water, which is H2O, is a compound. Table salt, which is NaCl, is a compound. It's made of atoms of sodium and atoms of chlorine that are bonded together. And it can be broken down into those elemental compounds, or those elements that make up the compound. So that's what makes up. Welcome back, this is Mrs. Benke, and this screencast is on matter and its properties. Matter is anything that has mass and takes up space. So your desk at school is matter. The floors, the chairs, a rock, a large boulder that you would see outside. Even the air that fills the spaces around us is matter. So mass is a measure of the amount of matter. It's not the same thing as weight. We often think that mass and weight mean the same thing, but they really don't. Volume is the amount of three-dimensional space an object occupies. Think of like length times width times height. That's your volume. So matter is going to contain mass and volume. Anything that has mass and takes up space, has volume, is matter. The basic building blocks of matter are atoms, elements, and compounds. An atom is the smallest unit of an element. You can't break an element down any further than an atom and have it keep its chemical identity as that element. So the atom is the smallest unit of an element. An element is a pure substance. It cannot be broken down into simpler, stable substances, and it's made of one type of atom. So if we're looking at the element carbon, every atom of carbon is going to look identical. It's made up of all atoms of carbon. A compound is a substance that can be broken down into simple, stable substances, and it's made by chemically combining two or more atoms of elements. So for example, table salt is sodium chloride, and it's made up of an atom of sodium chemically bonded to an atom of chlorine. So a compound can be broken down into the elements that make up the compound, but it's made of at least two, sometimes more elements that are chemically bonded to each other. Matter has physical properties and can undergo physical changes. A physical property is a characteristic that can be observed or measured without changing the substance. So for example, melting point and boiling point. This is often confusing, but kind of think of it this way. When we're talking about melting point, if you have an ice cube, that's just water that's been frozen. When it melts, it turns into liquid water. So we're still dealing with water, it's just in the frozen state, it's solid, and then once it's melted, it's liquid. Likewise, we can boil water and it can change from liquid water to gaseous water. But in all these cases, we're still dealing with water. The substance hasn't changed, just the way it looks. A physical change is a change in a substance that does not involve a change in the identity of the substance. So we're talking about changing the way something looks, not what it is. Grinding, cutting, melting, boiling, these are all examples of physical changes. Changing the state of matter is a physical change of the substance from one state to another. The states of matter are solid, liquid, gas, and plasma. In the solid state, matter has definite volume and a definite shape. Think again about the desk in your classroom. It takes up a definite amount of space and it has a definite shape. You can move it around the room, but that volume and that shape do not change. In the liquid state, matter has a definite volume but an indefinite shape. So you can take a gallon of water. It's a gallon of water inside of a container, and it's a gallon of water if you dump it out on the floor, but it doesn't have the same shape. In the gas state, matter has neither a definite volume nor a definite shape. We can take all the air that's in our classroom and we can squeeze it down to a small volume in an odd-shaped container. It's still the same amount of gas, but now it's taking up a different amount of space and it has a different shape. Plasma is a little different. Plasma is a high-temperature physical state of matter in which atoms lose most of their electrons, which are particles that make up atoms. So it's a little different, and we don't really deal with plasma much in class. In contrast, physical properties and changes are where we're going to change the substance. So a chemical property relates to a substance's ability to undergo changes that transform it into different substances. We're making something new. A change in which one or more substances is converted into different substances is called a chemical change or a chemical reaction. When we're dealing with chemical reactions, we have reactants and products. The reactants are what go into a chemical reaction, and the products are what you get out of a chemical reaction, and we'll be dealing more with these throughout the course. An example of this is when you combine carbon plus oxygen, which yields or forms carbon dioxide. So here we see our equation written out. We have carbon plus oxygen gas. Yields is kind of like an equal sign in a math class, carbon dioxide. So what we put into the reaction on the left side are called the reactants, and what we get out of the reaction, which is to the right of the arrow, are called the products. Evidence that a chemical change has occurred include the formation of bubbles or gas, a precipitate, energy, often in the form of light or heat, and a color change. So let's look at each of these examples. In this diagram, we see the combination of vinegar and baking soda. You may have done this in your kitchen or in another science class, and you know it foams and fizzes and it makes lots of bubbles. When we see those bubbles being produced, we know that a chemical change has occurred. Another key or evidence of a chemical change is when we form a precipitate. A precipitate is when a solid settles out of a liquid. In this case, we have cadmium nitrate, which is a clear liquid, being combined with sodium sulfate, which is also a clear liquid. And you can see in this picture that this solid yellow forms when we mix these two liquids. That solid is cadmium sulfide. It's pretty spectacular, bright yellow color. A precipitate doesn't always form as a yellow color, but it's always going to look cloudy, or it will be a solid that settles out of a liquid. In this next example, we see energy in the form of light and heat when we burn a magnesium ribbon. And finally, in this last example, we see a color change. Here we have a titration endpoint where we've had phenolphthalein added, and the liquid changes color to show that the reaction is complete. So evidence of a chemical change can be bubbles, formation of precipitate, energy in the form of light or heat, and a color change. Energy is always involved when physical or chemical changes occur, and the energy can be in the form of heat or light. However, you need to know that energy can be absorbed or released and changed, but it is not destroyed or created. So I can't make energy, I can't get rid of energy, it can just be changed. And that's called the law of conservation of energy. We've talked about a lot of different ways that we can classify matter. We're going to go into just another way here. Matter can form two basic categories. The first category is called a mixture. A mixture is a blend of two or more kinds of matter, each of which retains its own identity and its own properties. So they're mixed together physically, and usually they can be separated. There are two types of mixtures. Homogeneous mixtures are also called solutions, and these have a uniform composition. They look the same throughout. So if you look at the picture here of lemonade, we know that to make lemonade we squeeze lemons and we add sugar and water. When the lemonade's all mixed up, I can't look at the lemonade and pull out the sugar particles, and I can't separate the water from the lemon. It looks the same throughout. The other type of mixture is a heterogeneous mixture, which is not uniform throughout. So if you look at the salad here as our example, we can see the different parts, the lettuce, the tomatoes, the cucumbers, the bacon bits. Okay, and I can separate all those parts. If I don't like the bacon bits, I can pull the bacon bits out. I can easily see those separate pieces. So this is a heterogeneous mixture. The other main classification of matter is a pure substance, which has a fixed composition. Pure substances are either elements or compounds, and they differ from mixtures in the following ways. Every sample of a given pure substance has exactly the same characteristic properties. So every sample of carbon has the same properties as any other sample of carbon. Every sample of water has exactly the same properties of any other sample of water. Every sample of a pure substance has exactly the same composition. So for example, water is always 11.2% hydrogen and 88.8% oxygen by mass. So it doesn't matter where my sample of water comes from, it's always that same composition. So we've talked about a lot of information in this video. We've talked about chemical properties and physical properties. We've talked about the main types of matter being pure substances or mixtures, and pure substances can be elements or compounds, and mixtures can be heterogeneous or homogeneous. Make sure you take really good notes with this section. I know it's a lot of information, but this is going to be very helpful in upcoming assignments, so if you need to rewind, go back, make sure you catch a lot of the definitions, and if you have any questions, please make sure you bring them to class and ask Mrs. Benke.